So as you can see in this slide, in general, the beam mobility management in 5G massive MIMO, it's divided into two different categories, as you can see in the figure in the bottom left here, or in the summary in the top right, or in the right side of the slide. As you can see, first of all, you should know, based on this comment, the base station and UE must be capable of changing beams as the radio condition change. So whenever there is a radio condition being changing over time, for example, the UE or the device, the user is moving from one location to another at different timing and so on. So the UE will have a different radio condition. So the base station and UE should be capable of adapting for this radio condition change through adapting or changing the serving beam, right? So as you can see in the bottom left figure here, there are two different categories of beam mobility management in 5G. The first one is called intracell handover, which is beam switching, like whenever you change from one beam to another, but within the same sector. For example, here you're assuming you have three sectors. Sector one, number one, and this sector number one is served by different number of beams. For example, 8 beams or whatever, 8 SSB beams as an example, and you have sector number 2 with the same, then sector number 3. So, for example, assume now the user is moving from one beam to another, this third and fourth and so on. So the G node B should change the serving beam from the user to ensure that the user is being served by the best beam which have the best radio condition, which can guarantee that the user is served by the best beam to have the best coverage and so on, right? So usually this one is called, as you can see in the figure on the right here, it's called intra-cell mobility, which is just doing a beam switching, like changing from one beam to another, beam 1, beam 2, and beam 3. And this is usually done through the within the L1 and L2 procedures, which is the physical, and MacLear is handling this completely, which means that the beam changing, the unit beam might change the beam to the UE, and the UE at this particular case will be transparent and seamless. Like you will not understand, or you will not know that the unit B already changed the beam. Like this is, as you mentioned in this comment here, the beam level are transparent and seamless from the UE perspective. Okay, and can be done based on two different categories, or multiple categories or multiple inputs. For example, whenever the UE can report based on periodic CSI reports, for example, something called CRI or SSB-RI reporting, which is, if you remember from previous session, CRI refers to CSIRS resource indicator, and this is SSB resource indicator reporting, where the user is reporting through L1 and L2 the coverage of the served CSIRS beam or SSB beam, and telling him what is my coverage, what is the beam ID or beam index, so the unit B will know how to change the weight of the beam and start targeting a new, for example, traffic beam and so on. The second one, this will be covered in a complete different session, because this require like kind of more details which related to the enhanced TCI. This will be covered in different video. This is the first time of the beam mobility, which is called intra-cell mobility. I will be covering this in more details in the next slide as well, just to give you an overview about from draft test what you can see, and also what kind of parameters you might need to look into for both intra-cell and even intra-cell mobility. The inter-cell mobility actually, which is the second type, as mentioned in right figure here in the bottom right. This is whenever you change from one cell to another, even within the same site or for different sites. So you are doing a handover from, for example, cell 1 or sector 1 to sector 2 within the same site, or from sector 1, assuming there is another site outside here. So you're moving to another site to another site within different cell, right? So this is inter-cell mobility. Okay, it can be inter-cell, intra GMB, or inter-cell intra GMB, right? Handover. And this is typically is very like similar to whatever we used to have in general in the handover procedures, especially, for example, comparing to 4G, which was mainly relying on different events. A3, for example, which is was typically used for intra-frequency handover, and some particular cases you can configure it even for inter-frequency handover. And you have the A5, which is used typically for interfrequency handover. And this is mainly done through the RRC messages, which is called L3 procedures. This is require kind of RRC signaling involvement here. So it requires reporting from the UE to GMB, and the opposite way around. GMB need to deliver particular configuration and also need to inform the UE about the new target cell. While again, the main difference is to the intra-cell mobility, that this one is transparent to the UE, which is the intra-cell mobility with beam switching, where the GMB does not require to deliver any information to tell the UE about the new beam. Okay, this is just the main difference between both of them. In next slides, we'll be covering both of them with more details, more visualization, and also will include some of the parameters and optimization which is being done for different networks, just to give you a complete overview about the beam mobility procedures in the 5G Massive MIMO. And that's all about today's video. Again, I hope if you like the video to press like and to share the information and to spread the knowledge. And thank you very much and see you in the next video.